Bismillahirrahmanirrahim. Assalamu alaikum. Now I have to explain the Laurent series by solving some more problems. So let us start from this example. In this example, we are given a function f of z of the form this one, and we have to obtain the Laurent series first in the domain 1. The domain 1 is that z absolute is between 1 and 2. Then again we have to solve the problem and we have to obtain the Laurent series for this function in the domain 2. In the domain 2, z absolute is less than 1. And then the third problem, we have to obtain the Laurent series for this function in the domain 3 where z absolute is greater than 2. So let us start the solution. From the given function, we can write that f of z is equal to, if I take minus as a common, so I can write minus 1 divided by z square minus 3z plus 2. And now I have to factorize this function. So after the factorization, I will get that this is equal to z minus 1 into z minus 2. And now I have to use the partial fraction. So by the partial fraction, I can write that minus 1 over z minus 1 into z minus 2 is equal to a over z minus 1 plus b over z minus 2. And if I multiply with the LCM, I can get that minus 1 is equal to a into z minus 2 plus b into z minus 1. And let this is 1. So if I put z is equal to 1 in this equation, then this is 0. And if I put 1 here, I will get minus 1. So this minus and this minus will be cancelled, and I can get that a is equal to plus 1. Similarly, if I put z is equal to minus 2, z is equal to 2 in this equation, so then this will be 0. And if I put 2 here, then this is plus 1, and I can get from 1 that b is equal to minus 1. So my function f of z will take this form. F of z is equal to, now a is 1, so I can write that this is 1 over z minus 1. B is minus 1, so I can write this is 1 over z minus 2. And now I have to obtain the Laurent series in the domain 1. So in the domain 1, I have z absolute which is between 2 and 1. So now I have to take this function f of z, and first of all let us consider the first part of this function. And look at this note, always take the greater value as a common in a given domain, and the given domain in this case is this one. So now we have to look at these two terms, whether z is greater. If z is greater, we have to take z as common. If 1 is greater, then we have to take 1 as a common. So you can see from here that 1 is less than z. In other words, z is greater. So we have to take z as a common. So if I take z as a common, I will get 1 minus 1 over z. And now look at this one. If z is greater, we have to take z as the common. If 2 is greater, we have to take 2 as a common, but considering the given domain. And in the given domain, you can see that z absolute is less than 2, which means that 2 is greater. So we have to take 2 as a common from here, and we can get that this is equal to 2 into, this will be z by 2 minus 1. And if I take minus as a common as well, then I can obtain a little more simplified form, that this is minus 1 minus z divided by 2, and this will become plus. So just take minus 2 as a common, you will get plus 1 here, and here you will get minus z by 2, and minus and this minus will become plus. And now I can write that this is equal to 1 over z, and I can write this 1 minus 1 over z whole power minus 1. Similarly, 1 over 2, and this can be written as this one. So now I can use the binomial expansion for this one as well as for this one. So I can write that f of z is equal to 1 over z, and here this is 1 plus 1 over z square plus 1 over z cube and plus up to so on. And now plus 1 over 2, again I have to use the binomial expansion for this one. So I can get 1 plus z by 2 plus z square divided by 2 square and plus up to so on. So now I have to multiply 1 over z inside. Similarly, I have to multiply 1 over 2 inside. So I can get that this is equal to 1 over z plus 1 over z cube plus 1 over z power 4 and plus up to so on. And similarly, I can get 1 over 2 plus z by 2 square and plus z square divided by 2 cube and plus up to so on. And this is the required Laurent series of the given function in the given domain. So you can see that this is the principal part of the Laurent series, and this one is now the analytic part of the given series. So now let us solve the second part of this question. In the second part, you can see that again we are given the domain. The domain is given. The domain is that z absolute is less than 1. So again let us take the function. The function f of z is equal to 1 over z minus 1 and minus 1 over z minus 2. So now in the similar procedure we have to take common. So let us consider the first part. If one is, now the domain is only this thing. This is our given domain. So we have to consider only this domain. In this domain we can see that 1 is greater than z. So we can take 1 as a common. So we can write that f of z is equal to, let us take minus 1 as a common. So we can take minus 1 over, and this become 1 minus z because 1 is greater. Now if z is less than 1, so of course z is less than 2, and it means that 2 is greater than z. So we have to take 2 as a common from here, and we can get again taking minus 2 as a common, this will be plus, and we can get that this is equal to 2 into 1 minus z by 2. So you can see that by taking minus 2 common, this will become minus and this will become plus. So we can get 1 minus z by 2. And now we have to evaluate this function. So from here I can get that this is 1 minus z whole power minus 1, and this one is 1 minus z divided by 2 whole power minus 1. So let us use the binomial expansion first of all for this one. So f of z is equal to minus, this will be 1 plus z square and plus up to so on. Now plus 1 over 2, and I have to use the binomial expansion. So this is 1 plus z by 2 plus z square divided by 2 square is 4 and plus up to so on. Now let us multiply this minus and this 1 over 2 inside, so we can get that this is equal to minus 1 minus z square and minus up to so on, and plus this is 1 over 2 and plus this is z divided by 4 plus z square divided by 8 and plus up to so on. And now let us simplify. Minus 1 and plus 1 over 2 will give us so I will get that f of z is equal to minus 1 plus 1 over 2. It will give us minus 1 over 2. So I have to write minus 1 over 2. Now minus z and plus z by 4. It will give us minus 3z by 4. So I have to write minus 3z by 4. Now minus z square and plus z square by 8. It will give us minus 7z square by 8. So we can write minus 7z square by 8 and up to so on. So this is the required Laurent series for the given function according to the given domain. And now let us solve the same problem by considering the third domain. So in the third domain, we are given, in domain 3, we are given, in the third part, we are given that z absolute is greater than 2. This is greater than 2. And now I have to write the function. The given function is f of z is equal to minus, 1 over z minus 1 and minus 1 over z minus 2. So again, I have to use this note. So you can see that this note is very important for solving the problems of the Laurent series. So if z is greater in the given domain, I have to take z as common. If 1 is greater in the given domain, I have to take 1 as a common. So you can see that z is greater than 2, and of course 2 is greater than 1. So z is greater than 1. So we have to take 1 as a common. So I can write that this is equal to, let us take minus 1 as common, so I can obtain 1 minus z. Now here, you can see z is greater than 2. You can see from the first part that z is greater than 1. So I have to take z as a common. Always take the greater value as a common. So the greater value is z. So from here I can write that this is equal to, I will take z as a common. So this is 1 minus z minus z, minus 1 over z. Just take z as a common. If you multiply z, you will get z, and if you multiply here, you will get minus 1. Now again from here, z absolute is greater than 2, which means that this is the greater value, and I have to take the greater value as a common. So I have to take z as common. So here I will obtain 1 minus 2 by z. 1 minus 2 by z. And of course, if I multiply z inside, I will get z, and here I will get again minus 1. So now I have to simplify this function. So I will get that this is equal to 1 over z into 1 minus 1 over z power minus 1, and minus, again this is 1 over z into 1 minus 2 by z whole power minus 1. And now I have to expand this by using the binomial expansion. So I can write that this is equal to 1 plus 1 over z plus 1 over z square and plus up to so on. And now minus 1 over z. This is 1 plus 2 by z plus 2 by 2 square is 4 and z square and plus up to so on. Now I have to simplify this thing. Just multiply 1 over z inside. So you will get 1 over z. From here you will get 1 over z square. From here you will get 1 over z cube and plus up to so on. And if I multiply here, I will get minus 1 over z. Here I will get minus 2 by z square. And here I will get minus 4 by z cube and minus up to so on. Now plus 1 over z and minus 1 over z will be cancelled. And now from 1 over z square and minus 1 over z square, I can obtain that f of z is equal to, this is minus 1 over z square. Now from plus 1 over z cube and minus 4 over z cube, I can obtain minus 3. I can obtain minus 3 over z cube and minus up to so on. So this is the required solution for the given function. So till the next lecture, Allah Hafiz, Assalamu Alaikum.